All right, you guys, let's finish this off and simplify question number 29. So first of all, let's see if we can eliminate any answers. Let's just look at our numbers. Like literally, since everything's being multiplied, 6 divided by 2 is 3, right? 6 divided by 2 is 3. 3 squared is going to be 9. Okay, so our answer should have a 9 in it. So cool, I've narrowed it down. Worst case scenario, you have a 50-50 shot here. So we already know that our answer is going to have a 9 on the numerator. Okay, but what else is happening? What I'm going to go ahead and do here is for what's left over besides the numbers, if it's a negative exponent, I'm going to flip sides. So this says, remember, a negative exponent means it's just on the wrong side of the fraction bar. So instead of x to the negative 4 over x to the negative 1, I'll just have x to the positive 1 over x to the positive 4. And then I have y cubed and y cubed. And we already know from what we've eliminated that, well, I guess none of them had y's. Y cubed and y cubed are exactly the same. So no matter what happens on the outside when we square it, that's just going to cancel out. Now, remember, if I'm squaring a fraction, I'm just squaring the numerator. So it's going to be x squared. And I'm squaring the denominator. So x to the 4th times x to the 4th would be x to the 8th. Cool. If I expanded that, there is a rule you subtract the denominator exponent from the numerator exponent. But if you don't remember the rule, just expand it. X times x over 8x is down here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these two cancel, and I'm left with 1 over x to the 1, 2, 3, 4, 5, 6. So x to the 6th is on the denominator. There's a 1 on the numerator, but it doesn't matter. We're not going to put it next to the 9. But we have figured out that B is going to be the correct answer. All right. What is next? Oh, this one. You guys, we have done this problem so many times, I think. A manufacturer determines the number of sweatshirts it can sell is given by the formula S equals negative 2p squared plus 72p minus 200, where p is the price of the sweatshirt in dollars, determined algebraically, blah, blah, blah. So what's cool about this, you guys, is, let's just see if I can, if we just complete the square for this mofo, that means we're going to have the vertex. So minus 2p plus 2p squared plus 72p minus, oh, I thought I could remember, but I can't. Minus 2p plus 72p minus 200. Oops. Minus 200. The number of sales is equal to, and then P, I think, is our price, right? So when it says show algebraically, it means it needs to see you like doing the math work. So first thing I'm going to do is add that 200 to the other side. So to get rid of it from this side, and plus 200. So I have 200 equals negative 2p squared plus 72p. 72p. Now I can't complete the square if my a is not a positive 1, so I'm just going to factor that out. So 200 equals negative 2 parenthesis, okay? But you have to, technically you could factor out a p, but not if you want to complete the square because it needs to be a quadratic. So we're going to have, now that's a positive p squared, but since I factored out a negative, this next part instead of being positive is actually minus 72p. Okay, and then the next part is I'm going to take half of 72, oops, God, you guys, it's getting late. I not only factored out the negative, I factored out a 2. So half of 72, please tell me that's 36. So it's minus 36p plus, in order to finish completing the square right here, I take half of negative 36, which is negative 18. And negative 18 squared is what I'm adding here. When you square something, it's always going to be adding something here. And if memory serves, it's 324. What you do to one side, you have to do the other side. So normally you would be like, hey, let's add positive 324. But we're not just adding 324, we're adding negative 2 of them. So technically, we're subtracting 648. So instead of adding 324 to the other side, I have to subtract. So it's still, I guess, adding. We're adding a negative number. Subtract 648. Okay, and this seems counterintuitive because we're obviously going to get a negative number over here. We're going to get negative 448. And they're going to be like, whoa, what does that have to do with shirt sales? Well, that's because we're going to move it back to the other side. So we have negative 448 is equal to negative 2 times, and now we're going to factor the statement that we have above. So the two numbers that add up to be negative 36 and multiply together to be positive 324 are negative 18. So we're going to have that squared. Cool. Now add 448 back to both sides. And we have s is equal to negative 2 times x minus 18 squared plus 448. Now it's in vertex form. We know vertex form. This is going to be h, this is going to be k. But remember, x minus 18, what's the value with the x is going to be the opposite. It's actually going to be positive 18, right? So my vertex is going to be positive 18, positive 448, which means that we will sell 448 shirts for $18. And that's going to be our maximum. We're going to get, I don't know, something like this, right? And that's going to be our maximum value that we have. And you can tell, I'm trying to think of ways you can remember it's always the opposite here. If we were shifting this function, x minus 18 here actually means we're moving it to the right, right? So we're taking it, we're moving it positive 18. Does that help you remember here? This plus 448 out here, that still means we're moving it up. Okay. All right, so that has almost completed it. What we want to do is look at this here. And this was a little bit confusing. I think that the question on the test will actually be a bit easier to understand. But here we have g of x, which matches what it's saying of g of x here. And f of x, this function is f of x. Whoops, that was pretty terrible. This function is f of x here. And it wants us just to compare and contrast, like, some things that are happening. So let's look at the x-intercept. The x-intercept for this f of x is right here. Looks like a little bit more than 2.1, 2.2. And the x-intercept over here is where y is 0. And I'm not actually seeing where y is 0. But y is going to be 0 in between here, because here we have positive 3 and negative 2. Well, 0's got to be in between there somewhere, right? And positive 3 and negative 2, 0 is going to be in there somewhere also. So it looks like this one is a parabola somewhere between negative 2 and negative 3 here. And over positive 2 and positive 3 here. So it looks like it's going to be here. It's going down, then it's coming up. So my best guess for what that one looks like is this right here. Okay. So I guess if you're comparing and contrasting, f of x has one x-intercept and g of x has two x-intercepts, since we don't know exactly what it is off the top of our head. But other things we do know, I mean, you could create your entire equation out of this if you wanted to. Other things we do know the y-intercept here is -6. And the y-intercept over here on f of x is down here at -5. So f of x has a larger, the graph has a larger y-intercept than g of x, which this kind of now changes changes my problem, right? If we know that it's going to go down to -6, it's going to look kind of like that, right? And what else are we looking for? End behavior. The end behavior of f of x, the yellow line, as x is getting smaller, like this, it's going negative, right? And as x is getting bigger, it's going positive. So the ends are doing opposite things. The ends of the yellow line are doing opposite things. So the end behavior of f of x, as x goes positive is positive, as x goes negative is negative. And the end behavior for g of x, my blue parabola there, is that both sides of this parabola are going positive, right? That makes that an even function, and that makes the yellow function f of x an odd function. The odd function doesn't have symmetry. It looks like the even function, obviously the line of symmetry is somewhere here, right? And it would be symmetrical about that line. Let me see if I can find a better question. I can add that onto those weird questions that I didn't get to. And that way everybody can go to bed tonight. But let me know if you have questions over any of the ones that we weren't missing. And I will see you guys later.